Imagine plugging a standard, $20 monitor cable into your computer, tracing that wire through the wall, and somehow ending up right in the middle of NASA mission control.
Right, sounds totally crazy.
Yeah, but today's deep dive takes exactly that kind of turn. We are looking at this seemingly mundane product page for a 3-meter DVIGear DisplayPort cable. It's from a site called HDTV Supply.
Yeah, just your standard DVI-2803 AOC cable.
Exactly. But this single source actually opens a back door into this massive hidden world of military-grade video infrastructure.
It really does. I mean, it completely reframes what you probably think of as AV equipment.
Yeah.
Because the moment you click past that simple cable, you realize this site isn't just catering to someone wiring up a home office.
No, definitely not.
They are pushing massive industrial-scale hardware. Specifically, this brand called Wolfpack, which includes these giant matrix switchers that can route video to, like, 160 TVs simultaneously.
Okay, let's unpack this, because 160 screens isn't just a big sports bar.
Oh, no.
It's a logistical nightmare. Think of a 160 by 160 matrix switcher, like a colossal, high-speed train interchange. But these aren't just any trains, right? They are uncompressed 4K video feeds.
And uncompressed 4K is incredibly heavy. You are talking about roughly 18 gigabits of data per second, per feed.
Exactly. So if 160 of those massive freight trains hit the interchange all at once, you need an exact physical mechanism to route them to 160 different tracks.
Yeah, without a single collision or bottleneck.
Right.
What's fascinating here is how the hardware actually manages that terrifying amount of traffic. Because you can't just run this through standard computer software.
Wait, really? You can't just use a really fast processor.
No, absolutely not. To move thousands of gigabits of uncompressed video every single second without latency, these matrix switchers rely on dedicated silicon.
Oh, wow.
Yeah, the internal chips physically reconfigure their own circuits to create a direct, hardwired path for every single pixel.
That is wild.
It is. That raw, brute force processing is how it manages picture-in-picture and massive video walls without dropping a single frame.
Which, actually explains why the customer base listed on this site is so wildly specific.
Like the government portals.
Yeah. If you scroll down past the sports bar packages, you just hit this dense wall of government procurement portals. The federal GSA schedule, SAM.gov, TAA approved lists, and specifically the NASA SUP program.
Yeah, it really stands out.
It does. I mean, I get that government agencies buy tech, but seeing a dedicated NASA purchasing portal on a site selling HDMI cables seems like massive overkill. Like, are astronauts really requisitioning display cords?
Well, if we connect this to the bigger picture, it actually makes perfect sense.
Okay, how so?
NASA SUP, which stands for Solutions for Enterprise-Wide Procurement, is actually a massive contract vehicle.
Yeah.
And it's used by the entire federal government to buy secure IT products, not just NASA.
Oh, I see.
Right, so when a federal agency or a military branch is setting up a command center, they can't just buy commercial gear manufactured anywhere.
Right, because of espionage risks, I'm guessing? A compromised video switcher in a military operations center could be disastrous.
Exactly.
Which is why that TAA-approved label is front and center on the source page. It acts kind of like a security whitelist, right?
Spot on. The Trade Agreement Act, or TAA, legally mandates that the hardware has to be manufactured in the U.S. or in approved allied countries.
Okay, that makes a lot of sense.
Yeah, the whole goal is to prevent foreign intelligence from baking spyware directly into the silicon.
Because it's hardwired, like you said earlier.
Exactly. When mission control is monitoring a launch, or a defense base is tracking live satellite feeds, they require this highly regulated TAA-compliant hardware. It guarantees absolute fidelity over a closed, unhackable network.
It fundamentally changes how you perceive the screens all around you. I mean, next time you are waiting for a flight at the airport or checking the score on a massive stadium display, you will know there is likely a giant, physically hardwired matrix switcher humming away behind a locked door somewhere.
Just using dedicated silicon to force uncompressed video to exactly the right pixel. It really is the invisible physical backbone of our modern visual world.
It really is. But, it does leave you wondering about the future.
How so?
Well, right now, moving this much heavy, secure data requires hundreds of pounds of copper, silicon, and massive hardware boxes. But what happens to this entire physical ecosystem when video routing inevitably becomes entirely software-defined, just floating somewhere in the cloud?
That is a very good question.
It's definitely something for you to ponder the next time you just plug a simple cable into your monitor.